YUMIN Primary School. This lesson is Calculus, Chapter 6, Definite Integral. Well, for last few times, we have learned that the double integral, triple integral, and then so on, they're actually all definite integral. But if you say it is indefinite integral, well, that is because there's only one variable. One variable, you can just keep integrating. But remember, double integration has two variables, triple, 3, and so on. So remember, we've always used Cartesian coordinates or the rectangular coordinates. So what's so special about this time is that we'll start to use polar coordinates. So first we have these 4 circles. We'll write out the locus for each of these. So remember, for this, the x comes here plus 1, which is actually become minus 1. Y is still on this axis. Remember, the radius is a 1, so 1 squared is still 1. Then for this time is a y that go up. The x is at the y-axis. Like this. And then for this, which the x move, the y also move. Like this. And of course for this, which is the x squared plus y squared equals 1. Okay, so this is how we write it in Cartesian coordinates. But what if we change it into another form? So we'll start with this example now. So for this, remember, x is this part, y is this part. This is r, which for this case, it is actually the radius of this circle. So r will actually be a 1. But remember, x is r times cosine theta, because this is a right angle triangle. And therefore y, which is actually the r sine theta. So actually this square plus this square, well, this is actually the r square. So r squared is actually x squared plus y squared, and x squared plus y squared is a 1. R squared is a 1, r is a 1. But remember, for this r, we don't write it as a negative 1. So for this, because there is actually no negative length. Okay, so right now, after that, we can start from this. So remember, when you find this r, so this angle, this actually angle, is just a straight line. That is the central angle. Remember, you have different types of central angles. So for this type of central angle is 180 degrees. So from these 2 points, you can draw 2 lines that will intersect at the circumference. This angle will be called the circumferential angle. So how to calculate the circumferential angle? Central angle divided by 2. That is the circumferential angle. So it's 180 become 90. So this triangle is actually 90 degrees. Okay, so when you know that it is 90 degrees, of course it's a right angle triangle. So you can use our sine, cosine to find our r. So for this r, which is actually something like our height, our base, and this is our hypo. So theta is up here. It is adjacent to r, so we use the cosine. But remember, when you over the hypo is actually this diameter 2, like this. But remember, the range for theta is actually from here all the way up. So it's like this. But you might wonder, why can't we write it there in this place? Well, this is because that this is cosine, right? This 4 quadrants, here is for all, here is sine, tangent, and here is a cosine. So when it is here, and then you sub this in, you will realize that it's actually a negative. So at first when you want to draw here, it inverts back. So it's still at this place. So it's always here. So this is for our first one. How about this? Well, remember this time our theta is here and here. Okay. So for this part, r. Remember this time it is opposite our theta. And r, for this 2 case, it is not the radius. We call it the radial. So this time, which is our sine, and remember, theta bigger or equals to 0, here's pi. Like this. These two are together. These two, they can be together. Okay. So how about for this? Well, for this, remember, at first when it is at this middle, you move it, you shift. So x is actually 1 minus, or is it 1 plus? Okay, because you shift this, so it's actually a 1 plus. Well, sine or cosine? Well, is it just 1 plus cosine? So remember for this, we had the r. Like this, as we shift it upwards. So like this. Okay, so for this, remember the radius of this circle is actually r prime. And that's what it is written over here. So for this, remember we'll learn this in the future, how to write out in polar coordinates, okay? So right now for this, we can start on this question. So for this question, here a double integral the xy plus 1 dx dy. And for this, which case is it? Well, it is this case. For example, here we take out a little piece. Well, it is actually very weird that Cartesian coordinate x equals 1 is just a straight line down. Y equals 1, straight line horizontally. But if it is r equals 1, it's actually a circle. Well, this is actually, r is actually the length of this. But remember, it also can be here, which is actually from each of these points. When you sub in a number, it is actually this length. Remember, it must always be this length. If not, it will not be right. So remember for that, it's this case. And r is 2 cosine theta. Okay. So for this, I'll write this down. So at this place, dx, dy, remember we'll write it in the polar coordinates. So remember in polar coordinates, dx, dy will become the r dr d theta. So we'll integrate the r first. So for this part, x, y, well, what can we sub it as? Well, we can sub it in like this. We use that. Okay, now the problem is this range. So r, it actually goes like this. So that means it will go from, well, from the 0 to the curve. And remember, this curve is a 2 cosine theta. So for the theta, which is actually from this negative half pi to half pi, like this. And then after that, well, remember, don't use the double angle formula. If not, at last you'll realize that it'll get harder and harder. So for this, we can actually times this in and then integrate. So remember, here become an r cube, but cosine and sine still stays there. And here is an r. So here will be from 0 to 2 cosine theta. And here is d theta. So next, we can just sub them in. Oh wait, here is 1/4. So next for this, when we sub this in here, we can have a 4 cosine to the power of 5 theta sine theta. And here will be a 2 cosine square theta. Then next, for this, remember this part we use the double angle for cosine. So we can separate this. Like this. And then after that, remember, so this will become a 1 plus cosine 2 theta. So like this, we can already integrate them. So for this, you can just take this as x to the power of 5 and x. So 4 over 6 is actually just straight away a 2 over 3. So we can have it like this. And then after that, here. And for the cosine 2 theta, you need an actual half. Sine 2 theta. Sub in from negative half pi all the way to half pi. So here, cosine half pi, 0. Cosine negative half pi, 0. So that one, don't care. Sine pi, 0. Sine negative pi, 0. Also don't care. Now this part. So it's a half pi minus the negative half pi, which is a half pi plus a half pi. So the answer is actually a pi. Don't mistake this pi for the kind of pie that you eat. So this is actually how you solve it. So you see, sometimes Cartesian coordinates you cannot solve, but using the polar coordinates you can actually solve it. And this is actually very strange. So that is actually all for this time. So if you like our videos, don't forget to subscribe to our channel and stay tuned for more videos. So we'll see you in the next lesson. Thank you for your watching.